Okay, hello and good morning again. So I'm starting this secondary stream where I'm actually going to learn Rust, and this is just as unprepared as the other stream. So I kind of just read some stuff the evening before, and then I'll stream about it for half an hour the day after. And the intention is, like, for me, it's interesting to learn Rust because I've gotten to know, well, not a lot of different languages, but a few languages, and I have some opinions on how I think you write good code. And Rust really conforms with my opinions, it seems. So that's going to be interesting. The other reason is at Code Sandbox, we are building a pretty complex application, and Rust compiles down to WebAssembly. So it's interesting to explore that space, but not only on the client side, but also running Rust on server side, because we hopefully will have a ton of users, and having like super performant services running on the server side is also interesting. And Rust is one of the ways we can achieve that, because the way, like in the introduction for Rust, it's about, they talk about languages, like either it's like high level, kind of removing you from the complexity of memory management and concurrency, or you are deep down managing memory and concurrency. While Rust tries to be this thing in between, kind of go against what people generally think about that you can't do both. But they think they can do that, and that's going to be interesting to explore. Because that's been confusing for me in other languages, for example, in C# specifically, where you do work with multiple threads. So for me, coming from JavaScript, having a single thread, it's such less mental overhead than when you have to deal with multiple threads, especially when it's concurrent by default. So for example, when you write a C# code, you have to imagine in your head that that the code you're reading, it doesn't actually run the way you think about it, because you think about it as like a single user, as a single thread. It's like your brain is single threaded. And then, but you have to imagine that there can be multiple things accessing all this stuff at any point in time, especially related to mutating things. And it's super, super tricky. And then you have other languages like Clojure, where you have to be explicit about concurrency. So everything you read, all the code you read, the way I understand it at least, is that it's kind of single-threaded, and then you opt into concurrent behavior when it's needed. So I believe Rust is concurrent by default, but it's immutable by default as well, unlike C#. And sorry if I'm using terms here and things seems confusing, but I'm just trying to explain it from my perspective. What I hope this stream will do is like kind of battle some impostor syndrome, because sometimes it seems like people just get things. I'm not one of those people, and I don't think most people are. It takes time to understand concepts, and you have to figure out on your own how to think about things. It's not like I can just tell you, or nobody can just tell you how to think about something. You have to find your way of thinking about it. At least it's like that for me. So hopefully doing this, it will kind of, I don't know, inspire you or whatever. Or you just find it funny, me getting stuck and trying to explain things. So what I thought we could do first is, let's see, I'm just going to bring up so that my face doesn't get in the way here. So we're just going to install, I haven't even installed Rust here. So we're going to try that first. And the way you install Rust is you use curl rest up rs. I have no idea what these commands mean. SSF, no idea, but it actually runs a script. That's what I understand. Proceed with installation, probably. And cargo, this is something we're going to immediately look at. Cargo is like npm. It's what manages, it's kind of mix of, I guess, npm and create React app. So or like a boilerplate thingy, or a CLI. That's the best way to explain. It is a CLI that manages dependencies, and it can create your project. And there are two kinds of projects in Rust. You have bin projects, which are executable projects. And then you have library projects, which basically is non-executables, but you use them as dependencies in other projects. And what's interesting about Rust is when you compile it, you can just give that file to anyone and they can run it. They don't even have to have Rust installed on their computer. It just works, which is interesting. That's some takeaways. And let's see here. So what we're going to do now, we're going to try to actually create a project. And if I can remember this correctly, I think I have to close this window, by the way, and then open it again. Let's see. Let's go just a temporary. Do I have cargo? Woo! I have cargo. Great. There's supposed to be like a C compiler thing here as well. I don't know if I have that installed. We'll have to figure that out. But hopefully I have that. So what we're going to do, we're going to try to create cargo new demo app or something. And this is going to be a bin. So without this bin, it will become a dependency project, but with bin, it becomes an executable project. So we'll try that, and then new, demo app. And if we fire up Visual Studio Code here, we have some files. So yes, so I think I'm going to like, I'm not sure how I'm going to do this. Maybe I should just put my face over here. That's better. Dart code, what the hell? .NET Core debugger, installing C# dependencies? What the hell? Why is it doing that? Well, that's weird. Anyways, let's see. I can make things a little bit bigger here, like that. And the way I understand this is that this cargo file is just like package.json. It, oh, yes, let's install better TOML language support. I wonder if I can just find like a Rust. Is there some Rust for Visual Studio Code? I wonder, maybe that actually contains like TOML. It's kind of funny, like TOML files. It's, what was it? Like some Tom's obvious, anyways, it's kind of like Tom's obvious, what was it? TOML markup language or something like that. It's kind of funny. Anyways. Did this include? No. Okay, so let's search for TOML. Oh, sorry. Extensions. TOML. Better TOML. TOML language support. Which one of them? Okay, I guess. Oh, it wasn't. Syntax highlighting. Okay, I guess so. So we have that. Anyways, let's take a look at this. Couldn't start client, Rust language server. Rust up not available. Oh, that sucks. I do have rest up though. Oh, maybe I need to, oh yeah, I probably need to restart VS Code. Let's try that. Code. Yeah, so actually, maybe we'll spend all our time just getting things running here. But let's see. Some REST components not installed. Why does it say Dart? No. Oh, maybe this is the compile stuff. I don't know. I just install them. Press any key to close it. Okay, great. Anyway, so this TOML file is like package.json. It gives the name, the version, author here, edition, no idea what that is. And then this is where the dependencies are. And it also has a log file, just like npm and yarn. And it has the same purpose. So when you add a dependency here, it creates a log file. So with the actual installed version, so that if there's like a new version, it doesn't install it unless you explicitly tell it to. Okay, so it's consistent across computers and time, really. Cool. And then we have this target here, which is where when we build our app, it's kind of like our output, our out directory or our dist directory. And it should get like a debug folder and then a release folder when we build for production. That's what I understand. And then we have our source file and our hello world. And just like in other languages, I guess like in Elm and I guess also C#, you have like this main function. And this is always executed first. And then we are calling a function, but it's not really a function. It's something called a macro. And I no idea what macros are yet, but the exclamation mark here. So if I would do this, it would be a function call. But when I have an exclamation mark, it means calling a macro. And then we have a string. And this is how you express strings. You use double quotes. That means this is a string. Single quotes means something else. I'm not sure what I'm going to use that for, but it's related to like characters. It's like a type in Rust. Okay, so how much time do we have? Oh, we have some more time. Okay. So where should we start? Maybe we should try running this thing. So the cool thing is that you do have this lower level Rust CLI, but we can use cargo to like build the project and also run it. So maybe I can try to run it. Wow, my computer is really running like crazy now. I'm not sure why. Cool. Yeah, as you can see, we got our target debug demo app, and it actually ran it. It's also possible to just run check, which means that it just sees if the code can actually compile. And this is going to be interesting. Like, how is the development flow of this thing? I'm kind of used to having a development server, like auto refresh and all this stuff, but it seems that you don't have this here. You actually do. Like if it compiles and your tests run green, the application works, which is very fascinating. And I guess that points to the types of projects you would actually write in Rust. Like you wouldn't write a website or a web application in Rust. And I guess that's why we have a tendency to like have that flow. We need visual feedback to verify that our application works as intended, because you're going to interact with it, and you have CSS on top of that. But with applications built with like Rust, you don't have that same level of interaction, and you don't have like any visual validation really. It's more output. Anyways, so what we maybe could do here, what was the stuff I was learning about? Yeah, so we're going to build, like, there's this guessing game. That was kind of the first demo, which kind of had like user input and some validation and stuff, which was actually really interesting. So I think maybe we can try to build that. Can we build that in 15 minutes? Let's see. I'll try to do it. Okay, anyways, so there is this game which is called Guess the Number. And what we're going to do is we're going to print enter your guess, something like that. And then we get to our first thingy here, where we actually write some Rust code. So as I mentioned, this is macros, which is something new in Rust. And then we have variables. So you define a variable using let. You don't have var, but you have let. And you also have const. The thing is, const is something you specifically, like both of them are immutable. So when you write let foo equals bar, you cannot change this variable. That's not allowed. And the same goes for const. Foo. Right? The difference between them is that a const can absolutely never be changed, while a let, you can change them in two ways, or allow them to be changed, which we'll talk about later. Yes. So a const is more consty, unchangeable than let. And also a const can be used like up here, for example. I don't think you can use let up here. That should give like an error, I think. Yeah. But here you can use const, so you would actually use them as constants. Unlike in JavaScript, like it's crazy. They just seem to put everything in there. So in JavaScript, you use const as a variable because most variables shouldn't change. At least I do that. Yeah, that's like a huge discussion what these actually mean in JavaScript. But anyways, here they have a very explicit concept. So const would be like max size, something like that. Actually use them as constants. Anyways, so we have let. Now the thing is, we want the user to give us something, like give us a guess, which is a string. It comes from the terminal. And to be able to put something into a variable, you have to, or to change a variable, you have to give it this mutable keyword. So what we're basically saying now is that this guess variable can be changed. And what we can do here is point to string, and then we do double colons and new. And this is like, now it starts to look super crazy, but it actually makes a ton of sense. So string is, I think the right term here is a type. So it seems that in Rust, you kind of interchangeably use the term type to talk about something concrete and something that is an actual type. What I mean is, like in TypeScript, you would say like interface is a type, but class is a class. A class isn't a type, right? But here they seem to use it interchangeably somehow. I'll understand that better later. So the point is, we're pointing to, so you can imagine we're pointing to a class called string, really. And then what this means is it should use method on that class that is static. That's what it means. So doing this would be like instance method. I guess I'm trying to use the right terms here. The point is, like, this is how you would typically call a function, but when you do this, you're pointing to a kind of like a static method. And as I understand, a lot of the types in Rust has a new static method, basically for creating new instances. So what's interesting here, we are like in TypeScript, in JavaScript, you would just do something like this, right? But here we're actually kind of creating a container for that string so that it can be changed. That's the way I think about it, at least for now. Okay, so if we want to have some user input here, we have to import, well, we don't have to, but we can import, is this called a type? I'm not sure what you would call IO. Module? Yeah, module. IO is a module. I haven't gotten to modules yet. So IO is a module that contains a number of common things that you'll need when doing input and output. Yes, and they have something called traits, which is super, super fascinating. You basically, so you can have, I'll try to explain traits shortly. I haven't gotten to that part, but they briefly mentioned it. So instead of creating like a class definition where you implement all the methods of that class, you rather implement a type. And then whoever wants to can create traits for that type. So you kind of import the type and what operations you can do on that type separately. That's the way I think about it for now, at least. So basically what we're doing here, we're bringing in some traits. So let's see how we actually use this. So I don't have to do this. This is like doing, I'm kind of shortening it so that I'm able to do IO directly. I could do this directly as well. But yeah, like this. I don't know if I get any help with this. Yeah. Anyways, since I'm doing this up here, I don't have to put that in front. I can kind of shorten it down. So what does it tell me now? Yeah, I haven't really seen how. Ooh, this is really nice. Examples and mismatch types. Yeah, found struct, expected, blah, blah, blah. Try adding a semicolon. Interesting. So anyways, what happens now is that when I call this function, it gives me an instance of input, really, from the terminal. Yeah, I'm not getting any help like pointing further into this. That's interesting. So I kind of have to know this. That's kind of scary. Read line, what does it say here? It takes one, yeah, so it knows about all of this, but it isn't able to give me auto suggestions. That's a little bit, yeah, that's kind of tricky for discoverability. Maybe I'm missing some extension or something. But anyways, what if I do this? Yeah, this doesn't help me that much either. Maybe this is a good time to show something that's pretty cool. Is this cargo docs? Doc? Let's see. So what's kind of cool is that you can get a custom documentation for your project, so that you just run cargo doc and then it looks at your dependencies and then it kind of builds a website for you where you have all the API documentation. Wow, this took a long time. Okay, where is it? Doc. Yeah, here you go. Can I like do open or something? Oh yeah, here it is. Cool. Yeah, so maybe, yeah, what's this? IO? No. All crates, functions, main. Wow, this is interesting. Okay, so it didn't help me with my, I was hoping it had some documentation for IO, but it doesn't have that. But this is pretty cool. Like, you get your own documentation for your app. Huh, that's super interesting. Anyways, so let's just imagine that I actually know how to use this. And what we're going to do is, what you would typically do here, you would give it like a callback, right? So that whatever, you would do something like this. So you would get like input, and then you would say guess equals input, something like that. But the thing is, with Rust, you can actually pass, as I understand it, anything as a reference. So we can actually pass guess here, or is it like this, as a reference. So that means that there's an error here, and I'll explain it. That means that we are actually giving the actual guess string instance to readline, and it's able to change it from within, just like an object. Like in JavaScript, if you pass objects and arrays, it's by reference, meaning that the function receiving them can change them. And that's also allowed in Rust, but you have, and you can do with anything, it seems like, any type. But you have to be explicit about giving that ability, which means that if I only do this, well, I guess if I only do this, I guess I'm passing the value. If I do this, I pass the reference. And if I do this, I actually pass a mutable reference. I'm telling readline, you are able to change guess. That's it. Yes, and then there's this other super fascinating thing. So Rust knows that this is unsafe. Reading the input from the user, it can totally fail. So a lot of these functions, they return something called a result. And that's one of many different types it can return. So a result is either okay or error. Like either this thing went perfectly okay or something bad happened. So the way you would deal with this explicitly, it is related to something called matching. But we are not going to do that. We are going to use a method that's available on the result type called expect. Something bad happened. And what this does is, if it's an okay, nothing happens. Like it mutates guess and everything's okay. But if there's an error, it will actually, I don't know why they call it expect. It's really weird. But what it does is that if there's an error, it crashes the program with this message. That's basically what it does. Yes. And then we can do another like print line. You guessed. And then I had this really cool placeholder thing where I can just do this. That's pretty cool, right? And if I now cargo run, enter your guess, 5, you guessed 5. So that's actually running now. Okay, again, I don't know how valuable it is for me trying to explain something I don't really know much about. But I find it interesting that typically learning something on the web, you kind of get this, it's kind of like Facebook, everything's perfect. Like it seems like the person like knows everything about the thing, even though they don't. It's just very well prepared. While what we're doing here is like, I have no idea what I'm talking about there. I just read a couple of chapters in this book, and this is how I think about things. And then you can try to make up your own way of thinking about it. Yeah. again, I don't know how valuable it is. That's the experiment. Like, is this a good way to, is it a good way to learn? Is it just entertaining? Or is it like, no, this just confuses the hell out of me? So yeah, anyways, we'll try a couple of more sessions and see where it goes. Okay, cool. We actually did a lot of stuff here, so that's really nice. Okay, so next time we're actually going to talk about more of these types. I really want to talk about matches, which is really interesting how that works. And then you have like numbers and stuff. They have different kinds of numbers and all that good stuff. Loops. Yeah. So we can build a bit more on this app, and then we'll talk about matches and loops and all that kind of good stuff. And then I'll try to read some more, and then we'll see where it goes. Okay, cool. Bye for now. Talk to you later.